Hello, friend. Welcome to Science for Sleep. Did you know that some hot springs are fed by water that fell as rain, centuries, sometimes even thousands of years ago? Water that moves slowly downward through layers of stone, long before returning to the surface, warmed by heat held deep within the earth. Tonight, we're spending some quiet time with that process. Not as a destination, but as a slow exchange between water, rock, and time. Hot springs are often thought of as places people visit. But before they are places, they are processes. Long before anyone steps near them, water begins its journey far below the surface. Rain and snow fall gently onto the ground, soaking into soil and slipping downward through cracks in rock. That movement is slow enough to be measured in years, sometimes centuries. As the water sinks, it enters layers of the earth that are warmer than the surface above. Warmed not by weather, but by the steady heat held inside the planet itself. Earth remains warm beneath its crust because of energy left over from its formation and from the quiet decay of radioactive elements deep inside. That heat does not surge or flicker. It remains constant, spreading outward at a measured pace. When water reaches these warmer zones, it absorbs that heat naturally, without effort, simply by being present. As it warms, it becomes lighter, and over time, it begins to rise again, drifting upward through fractures and porous stone, following the same patient rules that guided it downward. This is how a hot spring begins. No force, no intention, just physics unfolding at a pace slow enough to feel timeless. You might imagine heat slowly spreading through stone, not rushing, just diffusing outward. Or picture water moving upward in narrow paths, invisible, until it finally meets open air. Steam may rise gently, thinning as it cools, never lingering too long in one shape. The surface world remains calm, while something ancient continues beneath it, uninterrupted. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. Hot springs exist in many places around the world, near volcanoes and far from them, because they do not depend on eruption or fire. They depend on time, on patience, on the simple truth that the earth releases its heat slowly and water listens. Some springs remain active for thousands of years, changing so little that generations pass without noticing any difference at all. That steadiness is part of what makes them feel grounding. There is comfort in knowing that something beneath the surface continues, whether we pay attention to it or not. The warmth does not ask anything. It does not hurry. It rises because it can, and it rests when it reaches the surface, spreading gently into the surrounding air. As we continue, there's no need to hold on to every detail. The mind can simply follow the movement, the slow descent and return, the quiet exchange between water and stone. Nothing here needs to be solved or remembered. It's enough to let the idea of warmth rising, little by little, take up just enough space to keep everything else from crowding in. As that sense of warmth rising lingers, it can be helpful to pause briefly with a question many people naturally carry when they think about hot springs. Are these waters actually safe to be near, to soak in, or to rest beside? The answer depends on the spring itself and understanding why brings us back to the water's long journey underground. The heat that warms hot springs comes from the Earth's interior, released slowly through natural geological processes. Some of that heat is produced by the gradual decay of radioactive elements deep in the crust. This decay happens far below the surface, locked within solid rock, and it releases energy as warmth rather than exposure. By the time water absorbs that heat and begins rising, it carries temperature, minerals, and dissolved gases. But it does not carry radiation in a form that affects people at the surface. The warmth arrives quietly, separated from its source by vast layers of stone. Safety, however, is shaped by more than heat alone. Each hot spring is its own system. Temperature, mineral concentration, acidity, and flow all matter. Some springs emerge at gentle, body-warm temperatures and have been used for bathing for thousands of years. Others rise extremely hot, sometimes near boiling, and are left untouched except for observation. Over time, cultures learned to recognize which springs invited rest and which demanded distance. Today, modern testing and signage help guide those same choices. With that clarity settled, attention can return to the water itself and how it reaches the surface at all. Long before warmth is felt, water begins as rain or snow, falling quietly onto the land. Some of it flows away immediately, moving across the surface into streams and rivers. Another portion seeps downward, drawn by gravity into soil and fractured rock. This descent happens slowly. Water threads its way through tiny spaces between grains of sand, along hairline cracks in stone, and through porous layers that act like underground passageways. As it sinks, the water moves farther from daily temperature changes. The warmth of sunlight fades, replaced by the steady thermal environment of the subsurface. With depth, temperature increases gradually. This increase is predictable, shaped by the geothermal gradient that warms rock a little more with each step downward. The water does not rush toward heat. It simply continues downward until conditions change. Pressure also increases as water descends. Surrounded by dense rock, the water is compressed slightly, altering how it interacts with minerals around it. Over time, elements from the surrounding stone dissolve into the water. Calcium, magnesium, silica, and other minerals enter quietly, one molecule at a time. This chemical exchange unfolds slowly, guided by contact and time rather than force. Eventually, the water reaches zones where Earth's internal heat is more pronounced. Here, warmth transfers gently from rock to liquid. No flame, no combustion, just energy moving from one material to another. As the water warms, its density decreases. It becomes lighter relative to cooler water above it. This difference sets the stage for the return journey. Rather than continuing downward, the warmed water begins to drift upward. It follows fractures, faults, and porous pathways, guided by the same openings that allowed it to descend. These pathways can be narrow or wide, straight or winding. Some lead directly back to the surface. Others curve, stall, or mix with cooler groundwater along the way. This mixing is one reason hot spring temperatures vary so widely. Throughout this slow circulation, the water remains enclosed within the earth. It does not encounter open air. It does not interact with surface life. The environment remains quiet and dark, shaped by pressure, warmth, and time. The journey can last decades, centuries, or longer. Each spring reflects a different timeline, depending on depth, geology, and flow rate. When water finally nears the surface, pressure decreases. Gases dissolved under higher pressure begin to separate, sometimes forming gentle bubbles. Heat escapes more readily. Minerals may begin to settle out of solution. The water that emerges carries with it the memory of where it has been, expressed through temperature, clarity, and composition. This is why hot springs differ so much from one another. Some emerge clear and mild. Others appear cloudy or richly colored. Some invite long soaks. Others are admired from a distance. The differences come from the path the water took, not from any single factor alone. As you picture this descent and return, it can help to imagine water moving without urgency, downward through stone, pausing where warmth gathers, then upward again, guided gently toward open air. Nothing here needs correction or intervention. The process continues whether anyone observes it or not, steady and self-contained. The warmth that reaches the surface has already traveled a long way. It arrives softened by distance, shaped by stone, and filtered by time. That long descent is what makes the return feel calm, predictable, and enduring. The earth does the work quietly, and the water follows. As water pauses in those deeper layers, another quiet presence becomes easier to notice. Beneath the surface, long below soil, roots, and groundwater pathways, the earth itself remains warm. This warmth is not seasonal. It does not respond to day or night. It is part of the planet's structure, held steadily within its interior. Earth's internal heat comes from two primary sources. One is residual heat left over from the planet's formation, when dust and rock slowly gathered and compressed under gravity. The other comes from the gradual radioactive decay of naturally occurring elements such as uranium, thorium, and potassium, locked inside solid rock deep below the crust. These elements release energy very slowly, over spans of time that stretch far beyond human lifetimes. The result is a consistent, gentle supply of heat that spreads outward through the surrounding material. This heat does not move in bursts. It does not flare or fade. Instead, it travels by conduction, passing from warmer rock to cooler rock, layer by layer. The process is so gradual that, on the surface, it often goes unnoticed. Yet measured over depth, the pattern becomes clear. For every kilometer traveled downward into the earth, temperature rises by a small but predictable amount. This increase is known as the geothermal gradient. Because of this gradient, rock several kilometers beneath the surface remains significantly warmer than the ground above it, even in cold climates or high latitudes. Snow, ice, and seasonal frost affect only the uppermost layers. Below that, temperatures remain remarkably stable. Water moving through these depths encounters an environment shaped not by weather, but by planetary physics. Not all regions of the Earth release heat in the same way. In some places, the crust is thinner, allowing warmth from below to reach closer to the surface. In others, faults and fractures act as natural channels, helping heat move upward more efficiently. Volcanic regions are one example, but they are not the only ones. Many hot springs form far from volcanoes, in areas where rock structure alone provides a pathway for warmth to rise. As groundwater settles into these warmer zones, heat transfers naturally from rock to water. No transformation is required. The water simply absorbs energy until it reaches equilibrium with its surroundings. Over time, this warming becomes enough to change the water's density, encouraging it to drift upward again. The process remains quiet and continuous, driven by balance rather than force. This steady internal heat has shaped Earth for billions of years. It drives plate movement, mountain building, and the slow reshaping of continents. Hot springs are one of the few places where that deep activity becomes gently visible at the surface. Rather than appearing as movement or noise, it appears as warmth. For people resting near a hot spring, this warmth can feel surprisingly calm. That calm comes from consistency. The heat does not surge. It does not demand attention. It arrives already settled, having traveled through layers of rock that buffer and moderate it along the way. What reaches the surface has already been softened by distance and time. This is why hot spring temperatures tend to remain stable across seasons. Summer heat and winter cold affect only the air above. Below the surface, the source remains unchanged. Water emerging today may be warmed by the same internal energy that warmed water centuries ago, released at nearly the same pace. As attention rests on this idea, it becomes easier to imagine the Earth not as something restless or volatile, but as something quietly regulated. Heat moves outward slowly. Water responds gently. Together, they form systems that persist without interruption. Nothing here requires effort or intervention. The warmth exists whether it is noticed or not. It continues its slow movement upward, meeting cooler layers, spreading softly, and eventually reaching open air. The planet releases its energy without urgency, and the water carries it patiently, 1 degree at a time. As warmth spreads through the surrounding rock and into the water held within it, a subtle shift begins to take place. Nothing sudden happens. There is no clear moment where movement starts. Instead, a difference slowly develops between warmer water below and cooler water above. That difference is enough. When water warms, its density decreases slightly. It becomes lighter than the cooler water surrounding it. In an enclosed system, even a small difference like this matters. Over time, the warmed water begins to drift upward, not pulled by intention, but guided by balance. Cooler, denser water settles downward as warmer water rises, creating a slow, continuous circulation beneath the surface. The pathways upward already exist. The same fractures, faults, and porous layers that allowed water to descend now offer routes back toward the surface. Some of these pathways are narrow, no wider than a thread. Others are broad enough to allow steady flow. Many wind and curve, changing direction as they pass through different types of rock. The water follows whichever routes are open, responding to pressure and gravity, rather than choosing a destination. As the water rises, conditions gradually change. Pressure decreases. Temperatures begin to soften. Minerals that dissolved more easily under higher heat and pressure may start to separate from the water. Tiny particles settle out, sometimes attaching to rock walls along the way. This slow exchange shapes both the water and the passage it travels through, refining the system over time. Not all warmed water completes the journey in one continuous rise. Some mixes with cooler groundwater partway up, lowering its temperature slightly. Some pauses in pockets where movement slows. Some takes decades to reach the surface after first warming below. These variations are why hot springs can differ so much even when they are close together geographically. Each spring reflects its own underground route. Eventually, some portion of that water reaches the final stretch upward. Rock layers thin, cracks widen. The influence of surface conditions becomes faintly noticeable. When the water finally emerges, it does so quietly. There is no announcement. It may pool gently, seep through gravel, or flow steadily from a small opening in stone. The warmth that reaches open air has already traveled far. At the surface, the water releases heat into its surroundings. Steam may rise briefly, especially in cooler air, then fade as temperatures equalize. Gases dissolved under pressure escape slowly. The water settles into its environment, spreading warmth outward rather than concentrating it in one place. This gentle release is what gives hot springs their characteristic calm. Because the system relies on balance rather than force, many hot springs flow continuously. As warmed water exits, cooler water from above begins its descent, replacing it. The cycle renews itself quietly. Old water leaves, new water enters. Heat transfers again. The pattern repeats without interruption. This circulation can persist for centuries or longer. As long as pathways remain open and internal heat continues to rise, the spring remains active. When conditions shift, the flow may change. Earthquakes can open new fractures or seal old ones. Mineral buildup can slowly narrow channels. In some cases, springs fade. In others, new ones appear nearby. Even these changes happen gradually, guided by geological timescales rather than sudden events. For someone resting near a hot spring, this long return journey is invisible. What is felt instead is the result. Warmth that feels stable, predictable, and contained. The water does not arrive hot and then cool rapidly. It emerges already moderated, shaped by its passage upward through layers of stone that buffer extremes. This return to the surface completes a cycle that began long before the water was warmed. Downward movement gave way to warming. Warming gave way to rising. Rising gives way to release. Nothing is wasted. Nothing is rushed. Each stage prepares the next. As attention follows this upward movement, it can be helpful to imagine water lifting gently, carried by difference rather than effort. Rising through dark spaces, guided by openings that already exist. Reaching the surface only when conditions allow. The journey completes itself naturally, and the warmth rests where it arrives, spreading slowly into the world above. Once water reaches the surface, one of the first things people tend to notice is temperature. Some hot springs feel softly warm, close to body heat. Others release visible steam into cool air. A few emerge so hot that they are left untouched, admired only from a distance. This range can seem surprising at first, but it reflects how differently each spring completes its underground journey. Temperature in a hot spring is not determined by a single factor. It is shaped by depth, distance traveled, mixing along the way, and how quickly water moves through the system. Water that descends deeper underground has more time to absorb heat. Water that rises quickly may retain more warmth. water that mixes with cooler groundwater along its ascent emerges gentler. These differences unfold quietly, long before the water reaches open air. Because underground temperatures change very slowly, many hot springs remain remarkably consistent once they form. Seasonal weather affects the air above, but the source of the heat lies far below where daily and yearly changes do not reach. A spring that feels warm in winter often feels nearly the same in summer. This stability is part of what makes hot springs feel predictable rather than surprising. Some springs emerge at temperatures close to the human body, which is why they have long been associated with rest and bathing. Others are warmer, requiring brief contact or careful design to allow safe use. In many locations, stone channels or shallow pools were built to cool water slightly before it was used. These adaptations develop slowly, informed by observation rather than urgency. It's also worth noting that water cools continuously once it reaches the surface. Heat transfers from water to air, stone, and surrounding ground. In open pools, evaporation removes warmth gradually. In flowing springs, heat disperses as water moves downstream. This cooling process happens naturally and steadily, smoothing out extremes rather than creating them. The presence of steam does not always indicate extreme heat. Steam forms when warm water meets cooler air, especially in cold environments. Even moderately warm springs can produce visible vapor on winter mornings. The visual effect may look dramatic, but the underlying temperature can remain gentle and stable. Differences in temperature also shape the environments around hot springs. Warmer zones tend to remain open year-round, even in cold regions. Cooler edges support more plant and microbial life. These gradients form naturally without sharp boundaries, creating gradual transitions rather than abrupt changes. Because temperature varies so widely, hot springs are often categorized locally rather than universally. What is considered warm in one region may feel hot in another. Cultural practices adapt to these conditions, shaping how springs are approached and used. Over time, familiarity replaces uncertainty. The water becomes known. Importantly, warmth from hot springs arrives already moderated by its long path upward. It is not sudden heat. It does not spike or surge. It reaches the surface having passed through layers of stone that buffer extremes. This moderation is why the warmth often feels enveloping rather than sharp. For the body, steady warmth tends to be easier to respond to than rapid change. Muscles loosen gradually. Circulation adjusts smoothly. There is time for the nervous system to settle rather than react. This pacing mirrors the spring's own behavior, unfolding without urgency. As you imagine different springs around the world, it can help to picture temperature as a spectrum rather than a single point. Some springs release warmth barely above the surrounding ground. Others hold heat close to the surface. All are shaped by the same underlying principles, expressed differently through geography and time. Nothing about this variation needs interpretation or concern. It is simply the surface expression of many quiet paths taken below. Each spring arrives at its own balance point, releasing heat at the pace allowed by its structure. The result is warmth that feels earned rather than imposed. As attention rests on this idea, temperature becomes less about numbers and more about continuity. Warmth rises, spreads, and settles. It remains long enough to be felt, then moves on, making space for the next cycle to begin. As warmth becomes familiar, we'll look at what the water carries with it. Well before a hot spring reaches the surface, water is already changing, not in ways that are visible, but in ways that are quietly cumulative. As it moves through rock, it gathers small traces of the earth itself, held in solution as it travels. Water is an effective solvent. As it flows through underground layers, it comes into contact with a wide range of minerals embedded in stone. Over time, tiny amounts of these minerals dissolve into the water, molecule by molecule. This process does not require force. It happens simply through contact and duration. The longer water remains underground, the more opportunity it has to interact with the materials around it. The specific minerals carried by a hot spring depend entirely on the geology it passes through. In some regions, water dissolves calcium from limestone. In others, it carries magnesium, sodium, sulfate, or silica. Each mineral enters the water in small concentrations, often invisible, altering its chemical makeup without changing its appearance. What emerges at the surface is still water, but water shaped by its path. Silica is one of the most common minerals found in hot spring systems. It dissolves easily at higher temperatures, remaining suspended in the water as it rises. Calcium carbonate behaves differently, often staying dissolved underground, but separating out as water cools near the surface. These differences matter later when water slows and minerals begin to settle. As water moves upward, pressure decreases and temperature softens. These changes affect how much mineral content the water can hold. Some minerals remain dissolved all the way to the surface. Others begin to separate out gradually, attaching to rock walls or settling as fine particles. This process is slow and continuous, shaping both the water and the space it moves through. What's important here is that none of this happens abruptly. There is no clear boundary where water becomes mineral-rich. Instead, chemistry unfolds as a quiet conversation between liquid and stone, sustained over time. Each spring reflects a different balance, determined by depth, temperature, and the type of rock encountered along the way. When hot spring water reaches the surface, these dissolved minerals are still largely invisible. They do not float or shimmer. They are present as part of the water itself. Only when conditions change further, as water cools, evaporates, or slows, do their effects become noticeable. Until then, they move silently, carried along. This is why hot springs can feel different from one another, even when temperatures are similar. The water's mineral content subtly affects texture, buoyancy, and interaction with skin. Some springs feel softer, others feel slightly heavier. These sensations are physical, not imagined, shaped by dissolved particles too small to see. Because mineral content reflects geology rather than human influence, it tends to remain stable over long periods. Springs that have flowed for centuries often carry similar compositions today as they did long ago. The chemistry changes slowly, if at all, guided by rock layers that themselves shift only over geological time. It can be helpful to imagine this mineral movement visually, even though it cannot be seen. Picture water passing through stone like breath through fabric, picking up faint traces as it moves. Each mineral particle joins the flow, travels upward, and eventually reaches the surface, still dissolved, still moving. This invisible carrying is part of what makes hot springs feel grounded. The water is not separate from the earth it rises through. It is shaped by it, altered gently, and returned carrying pieces of its journey within it. The minerals are not additives. They are records. As attention rests here, chemistry becomes less about formulas and more about motion. Dissolved particles drifting, suspended without effort. Water continuing upward, unchanged in form but enriched by contact. Everything remains quiet, balanced and slow, preparing the way for what happens next when movement begins to leave visible traces behind. As water slows near the surface, something subtle begins to happen. What was carried invisibly for much of the journey starts to leave a trace behind. The minerals dissolved during the long passage underground now encounter new conditions, cooler temperatures, lower pressure, open air, and in response, they begin to settle. This settling does not occur all at once. It unfolds gradually, one microscopic layer at a time. As hot spring water flows over rock or pools at the surface, small amounts of mineral content separate from the water and attach to nearby surfaces. Each deposit is thin enough to go unnoticed in the moment. But over years, decades, and centuries, these layers accumulate. Calcium carbonate is one of the most familiar minerals involved in this process. When water rich in calcium reaches the surface, carbon dioxide can escape into the air. This shift causes calcium carbonate to precipitate out of solution, forming a solid layer. Over time, these layers stack gently, creating smooth terraces, ridges, and shallow basins shaped entirely by flowing water. Silica behaves differently. It often remains dissolved underground, then settles slowly as water cools and evaporates. Silica deposits tend to form smooth, pale surfaces that feel almost polished. Unlike sharp rock formations shaped by erosion or force, these structures grow quietly, built by repetition rather than impact. What makes these landscapes especially calming to observe is their pace. There is no visible motion in their creation. Standing beside a hot spring, nothing appears to be forming. Water flows, steam drifts. Yet beneath that stillness, minerals continue to accumulate. A surface that looks unchanged today may be measurably thicker centuries from now. Because deposition depends on consistent flow, these formations often mirror the movement of water itself. Curves follow channels. Ridges mark former waterlines. Terraces reflect where pools once stood. The shapes are records of motion, preserved slowly as stone. This process requires patience from both the water and the environment around it. A single interruption, a change in flow, a blocked channel, a diverted stream, can alter how and where minerals settle. Over time, landscapes adjust. Old terraces may dry, new ones may begin forming nearby. Nothing here is fixed, but everything changes slowly. Some of the world's most recognizable hot spring landscapes are the result of this quiet building. Their scale can give the impression of design, but no planning is involved. Gravity, chemistry, and time do all the work. Each drop contributes equally, regardless of where it lands. What's important to notice is that these formations are not carved out. They are added on. Unlike canyons or cliffs shaped by removal, Hot spring terraces grow by accumulation. This gives them a softness, even when made of stone. Edges round naturally. Surfaces smooth themselves over time. For the mind at rest, this kind of growth feels different from sudden change. There is no urgency, no climax, just repetition. Water flows, minerals settle, layers form. Then the process repeats. The outcome is visible only because of how long it continues. These landscapes also demonstrate how small actions can shape large outcomes without effort. No single drop matters more than another. No moment stands out. Yet together, they produce structures that last far beyond individual lifetimes. This perspective can feel grounding, especially when attention rests on the idea of time passing gently rather than quickly. As you imagine terraces forming, it can help to picture water spreading thinly across stone, leaving behind a faint residue each time it passes. The residue dries, hardens, and remains. Then water passes again. The pattern repeats without awareness of itself. In this way, hot springs quietly write their history onto the surface. Each layer marks another cycle completed, another return finished, another exchange between water and earth resolved. The landscape grows not because it tries to, but because the process continues, calmly and for the foreseeable future. As mineral layers continue to form quietly, another presence becomes noticeable along the margins of hot springs. Life appears here not suddenly, but gradually, settling into places where conditions allow. It does not dominate the scene, it adapts to it. The water emerging from a hot spring is often low in oxygen and high in heat, creating an environment unlike most surface waters. For many forms of life, these conditions would be difficult to tolerate. Yet at the edges of hot springs, where temperature and chemistry shift gently, certain microorganisms find a narrow range where they can persist. These organisms are often microscopic, invisible individually, but noticeable when they gather. Known broadly as thermophiles, they are adapted to warm environments and have developed ways to function where others cannot. Their presence does not change the flow of the spring, it simply accompanies it. Different microorganisms thrive at different temperatures. Near the hottest parts of a spring, only a few specialized species are able to survive. As water cools outward, diversity increases. This creates gradual zones rather than sharp boundaries, with each zone supporting organisms suited to that exact range of warmth and chemistry. The colors sometimes seen around hot springs come from these microbial communities. Reds, oranges, greens, and browns emerge as pigments produced by different species. These pigments help the organisms manage energy and protect themselves from heat. The result is a visual gradient that mirrors the temperature gradient of the water itself. What's important to notice is that these colors do not signal activity in the usual sense. There is no visible movement, no growth that can be watched moment by moment. The changes happen slowly, as populations adjust to stable conditions over time. Standing nearby, everything appears still. These microbial mats form thin layers along rocks and sediment. They cling gently, shaped by water flow and mineral surfaces rather than by competition. When conditions shift slightly, the mats adjust. Some areas thin, others thicken. The overall pattern remains calm and balanced. Hot spring microorganisms have helped scientists understand the range of conditions life can tolerate. Their existence shows that life does not require mild environments to persist. It requires consistency. Where temperature, chemistry, and flow remain stable, even extreme conditions can support living systems. Despite this scientific importance, the organisms themselves remain quiet. They do not alter the spring's behavior. They do not consume its energy in noticeable ways. They exist alongside the process rather than driving it. Their presence adds texture, not noise. At the edges of springs, where warmth fades into cooler ground, these communities become more diverse. Mosses, algae, and bacteria appear, blending gradually into the surrounding landscape. The transition is seamless. There is no line where life begins, only a slow increase in complexity. This gradual blending can feel calming to observe. There is no struggle visible here, no urgency. Life meets the conditions provided and responds accordingly. When conditions change, life shifts with them. Nothing resists, nothing forces itself forward. It can be helpful to imagine these organisms not as active agents, but as patterns formed by stability. They are present because the environment allows them to be. When warmth recedes, they recede. When minerals accumulate, they adjust. Everything remains in quiet conversation with the water. For the mind at rest, this kind of life feels different from the movement of animals or the growth of plants. It does not demand attention. It does not perform. It simply occupies space gently, shaped by heat, chemistry, and time. As attention lingers here, the edges of hot springs can be seen as meeting points rather than boundaries. Warm water meets cooler air. Dissolved minerals meet solid surfaces. Simple life meets conditions that support it. Each meeting is gradual, without sharp contrast. Nothing in this system rushes. Nothing needs to be interpreted. Life appears where it can, remains where it fits, and fades where conditions soften. The spring continues to flow, minerals continue to settle, and these quiet living layers rest alongside the process. Warmth eventually leaves the water and enters the air, and the experience of a hot spring expands upward. What was once contained within stone and liquid begins to mix with the space above it. This exchange happens quietly, just as everything else has, guided by temperature and pressure rather than effort. When hot spring water reaches the surface, it carries more than heat and minerals. It also carries dissolved gases that were held within the water under higher pressure underground. As pressure decreases near the surface, these gases are released gradually, slipping out of solution and into the surrounding air. One of the most common gases released is carbon dioxide. It is colorless and odorless, and it disperses easily into the atmosphere. Its presence is usually unnoticed, blending seamlessly with the air around the spring. Carbon dioxide release is a natural part of the underground journey completing itself, another quiet adjustment as conditions change. In some springs, small amounts of hydrogen sulfide are also present. This gas has a distinctive sulfur-like scent that some people notice immediately, while others barely register it. The smell can seem strong at first, but it often fades quickly as the gas disperses and the senses adjust. The presence of hydrogen sulfide reflects the chemistry of the rock the water passed through. rather than anything happening at the surface. These gases are released slowly, without bursts or pressure. There is no buildup, no accumulation. The air around a hot spring remains open and moving, allowing everything to disperse naturally. This steady exchange keeps the environment balanced and predictable. Alongside gases, heat itself rises into the air. Warm water transfers energy to cooler surroundings, and that energy moves upward. When the surrounding air is cool, this transfer becomes visible as steam. Steam forms when warm, moist air cools rapidly, causing water vapor to condense into tiny droplets that catch the light. The appearance of steam can feel dramatic, especially in colder environments, but the process behind it is simple and gentle. The steam drifts upward, thins, and disappears as it mixes with the surrounding air. Nothing remains suspended for long. The shapes formed are temporary, changing continuously without repeating. Steam does not indicate intensity on its own. Even moderately warm water can produce visible vapor when the air temperature is low. The visual effect reflects contrast rather than heat level. What looks active is often simply the result of warm air meeting cooler space. Sound also plays a role here. The release of gas and heat can produce faint bubbling, soft hissing, or the steady murmur of flowing water. These sounds tend to be low and repetitive, blending into the background rather than standing out. The ear registers them without needing to focus. Repetitive natural sounds like these often encourage a relaxed state of attention. They lack sharp changes. There is no clear beginning or end to listen for. The sound continues at its own pace, allowing the mind to settle rather than track. Air movement around hot springs tends to be gentle as well. Warm air rises slowly, drawing cooler air toward the surface of the water. This creates subtle currents that refresh the space continuously. Nothing feels stagnant. Everything moves just enough to remain comfortable. As gases disperse and steam fades, the air returns to stillness. The cycle repeats quietly. Warmth rises, vapor forms, air mixes. Then the space clears again. This repetition mirrors the larger cycles happening below, expressed here in lighter form. It can be helpful to imagine breath moving in a similar way. Inhaling brings warmth inward. Exhaling releases it outward. The exchange happens without effort when allowed to remain natural. Around a hot spring, the environment breathes in its own way, guided by temperature and openness. As attention rests on the air above the water, there is nothing to monitor or assess. Gases release and disperse. Steam forms and vanishes. Sound continues softly. Everything behaves as expected, following patterns that remain steady and familiar. This gentle movement upward completes another layer of the hot spring experience. Water meets air, heat meets space. What was carried underground is released without demand. The atmosphere absorbs it easily, and the space above the spring remains calm, open, and ready for the next quiet exchange. After water has completed its long journey, and warmth has settled into the air above it, people begin to appear again, quietly, at the edges of the scene. Human presence around hot springs did not begin as recreation. It began as recognition. Long before written records, people noticed places where water emerged warm from the ground. These locations stood out in cold seasons, when snow remained on surrounding land, while steam drifted gently from the surface. The contrast invited attention, not urgency. Warmth offered rest, relief, and continuity in environments shaped by change. Early human use of hot springs left few permanent marks. People came, soaked, rested, and moved on. The water flowed as it always had. Archaeological evidence suggests that hot springs were visited repeatedly across generations, often becoming familiar gathering places rather than destinations to be claimed or altered. In many regions, these waters were approached with care. Temperature was observed. Flow was respected. People learned which springs invited closeness and which required distance. Knowledge passed slowly, shaped by experience rather than instruction. Over time, familiarity replaced uncertainty. Hot springs were often encountered along migration routes or near settlements, not because they were chosen deliberately, but because water itself shaped where people traveled. Warm springs became pauses along longer journeys, places where movement slowed naturally. Rest happened without planning. Unlike constructed baths, natural hot springs required no preparation. They were already warm, already flowing, already stable. People entered these environments as guests rather than builders. The role was simple: arrive, adapt, and leave without disturbance. The physical effects of warm water were felt immediately. Muscles softened, cold receded, circulation adjusted. These responses required no explanation. They were experienced directly, reinforcing return visits without the need for ritual or belief. Over time, repeated use shaped behavior. People learned when to enter and when to wait. They noticed how long warmth lingered after leaving the water. They recognized that calm often followed immersion. These observations accumulated quietly, becoming part of collective understanding. What's notable is how little changed in the springs themselves. Human presence did not alter their temperature, flow, or chemistry. The water continued rising, releasing heat, dispersing gases, and moving on. People fit into the system without redirecting it. This relationship contrasts with many other human interactions with natural resources. There was nothing to extract, nothing to store. The benefit came from proximity rather than possession. Once warmth was felt, it could not be carried away. It remained where it was. Because of this, hot springs often became neutral spaces. They were not fields to be worked or shelters to be defended. They invited stillness rather than activity. In some cultures, conversation softened here. In others, silence became customary. Either way, the environment guided behavior, rather than the other way around. As populations grew and settlements formed, hot springs remained points of return. Even as tools improved and structures developed elsewhere, these waters continued flowing unchanged. Stone might be placed nearby, paths might form, but the water itself remained unaltered. For the mind at rest, this kind of interaction feels grounding. Humans do not arrive to fix, harvest, or reshape. They arrive to experience what is already present. The role is receptive rather than active. It can be helpful to imagine early visitors approaching the water slowly, testing temperature with hands or feet, listening to the sound of flow, watching steam drift upward. Nothing needed to be decided quickly. the spring revealed its nature on its own timeline. This gentle return of humans does not interrupt the story of the hot spring. It simply adds another layer of presence. Water continues its cycle. Heat continues rising. Minerals continue settling. People arrive, rest, and depart, leaving the system as they found it. As attention lingers here, human presence can be seen as another quiet element within the broader pattern. One more participant responding to warmth, guided by comfort rather than control. The spring remains central. The water leads. Everything else follows. As generations passed, the quiet relationship between people and hot springs continued, deepening without needing to be defined. What began as recognition gradually became tradition, not through formal instruction, but through repetition and memory. In many regions, hot springs were returned to again and again, often by the same families over long periods of time. Children learned the shape of the water from those who came before them. Paths formed gradually, worn by feet rather than designed. The springs themselves remained unchanged, flowing as they always had, while human presence settled into familiar patterns around them. Over centuries, different cultures developed their own ways of approaching these waters. Some emphasized shared bathing. Others favored solitude. Some built simple stone boundaries to contain the flow. Others left the spring entirely natural. Despite these differences, the underlying relationship remained the same. People adjusted to the spring rather than expecting the spring to adjust to them. In places where hot springs were incorporated into daily life, they often became markers of continuity. Seasonal changes came and went. Settlements shifted. Yet the water remained warm, available in the same place year after year. This consistency offered reassurance. It became a quiet constant in a changing world. The Romans are often cited for their extensive use of hot springs, constructing baths around natural sources across their territories. While these structures introduced architecture and social space, the water itself remained unchanged. Heat still rose from below. Flow still followed the same underground paths. Human design framed the experience without altering the source. In East Asia, particularly in regions shaped by volcanic geology, hot spring bathing became woven into everyday routines. The act of soaking was not rushed. It followed patterns shaped by observation and respect for temperature and flow. The spring set the pace. People followed. In other parts of the world, hot springs were treated as places of quiet significance, not always named, not always formalized, simply returned to. In many indigenous cultures, these waters were regarded as long-standing features of the landscape rather than resources to be claimed. Their persistence over time gave them meaning without requiring explanation. What ties these very practices together is restraint. Across cultures, hot springs were rarely altered in ways that disrupted their natural behavior. Channels were guided gently. Pools were shaped minimally. Excessive change was avoided, not through rule, but through familiarity. This continuity allowed knowledge to accumulate slowly. Which pools were warmer? Which cooled faster? How long to remain? When to enter? These details were learned through experience, passed on without urgency, and adjusted as needed. Nothing here required reinvention. The social atmosphere around hot springs often reflected the environment itself. Voices softened, movement slowed, time was measured differently. In many traditions, bathing was separated from work and obligation, creating a space where activity paused naturally. Even as societies modernized, these patterns persisted. Hot springs remained places where expectations relaxed. The experience did not demand productivity or efficiency. It offered something simpler: warmth that could be felt and then released. For the mind at rest, this long cultural continuity reinforces a sense of belonging. People across time responded to the same conditions in similar ways, guided by comfort rather than instruction. The spring did not change. Human behavior adapted around it. It can be helpful to imagine generations arriving at the same place, noticing the same warmth, feeling the same release, and leaving with the same quiet calm. The details differ. The response remains familiar. Through centuries of use, hot springs became more than physical features. They became reminders of patience, of systems that outlast individuals, and of practices that require nothing more than presence. The water continues flowing, the warmth continues rising, and people continue returning, fitting themselves gently into a pattern that was already there. When people settle into warm water, the first changes happen close to the surface of the body. There is no signal announcing the shift. Instead, warmth spreads gradually, and the body responds in kind, adjusting quietly rather than reacting. When skin comes into contact with warm water, temperature sensors near the surface begin sending information inward. These signals do not trigger alarm or urgency. They simply indicate that the environment is warmer than before. In response, small blood vessels near the skin begin to widen, a process known as vasodilation. As blood vessels widen, blood flow increases in the areas closest to the water. More warm blood reaches the skin, and heat distributes more evenly across the body. This redistribution does not require effort or intention. It happens automatically, guided by built-in regulatory systems designed to maintain balance. The increase in circulation near the surface has a noticeable effect. Skin feels warmer, limbs feel heavier. Areas that previously held tension may begin to soften as blood flow improves. The body shifts from conserving heat to sharing it, allowing warmth to move freely rather than staying concentrated. This outward flow of warmth also supports internal regulation. As blood circulates more easily, connective tissue receives more oxygen and nutrients. Waste products are carried away more efficiently. These changes are subtle, but they contribute to a general sense of ease that many people notice without being able to name. Importantly, this increase in circulation unfolds steadily. There is no spike or surge. The body does not rush to adapt. It follows a predictable sequence, widening vessels gradually and adjusting flow until a new equilibrium is reached. This steadiness mirrors the behavior of the hot spring itself. Because hot spring temperatures tend to remain stable, the body does not need to constantly readjust. Once circulation increases, it can remain at that level without interruption. This consistency allows muscles and joints to settle rather than brace against changing conditions. Warmth near the surface also affects how the body interprets sensation. As blood flow increases, nerve endings in the skin transmit fewer signals related to cold or discomfort. Attention naturally shifts inward, away from external stimuli. the environment feels less demanding, and the body responds by lowering unnecessary tension. This response is not limited to one area. As circulation improves in the skin, it also influences deeper tissues. Muscles receive more blood. Tendons and ligaments benefit from increased warmth. Movement becomes easier, even when no movement is occurring. The body feels supported rather than held. For many people, this change is accompanied by a sense of spreading calm. Shoulders drop slightly, jaw muscles loosen, breathing becomes slower and more regular. These adjustments are not commanded. They emerge naturally as the body recognizes that it is in a warm, stable environment. It can be helpful to imagine blood vessels responding like gentle pathways opening wider, allowing flow to pass without resistance. Nothing forces them open. They widen because conditions allow them to. Warmth signals safety, and the body responds by sharing resources rather than guarding them. This redistribution of warmth also prepares the body for deeper relaxation. By improving circulation at the surface, internal systems are free to shift toward maintenance and recovery. Energy is no longer directed toward preserving heat. It can be used elsewhere, quietly and efficiently. Attention rests here. There is no need to track these changes closely. They occur whether they are noticed or not. Warm water surrounds the body. Blood flows a little more freely. The surface warms, and with it, the sense of effort fades. The body does what it has always done in warm environments. It opens, it shares, it settles. Circulation adjusts gently, setting the stage for the deeper release that follows as muscles begin to let go more completely. Circulation increases as warmth spreads evenly through the body. Then, another shift begins to unfold more deeply. Muscles, which spend much of the day responding to gravity, posture, and movement, begin to receive a different set of signals. The environment has changed, and the body adjusts accordingly. Muscles maintain tension through constant communication with the nervous system. Even at rest, small signals travel along nerves, keeping muscle fibers slightly contracted. This baseline tension helps support posture and readiness, but it also means that muscles are rarely fully relaxed. Warm water gently alters this pattern. Heat affects how nerves communicate with muscle fibers. As temperature rises, the sensitivity of muscle spindles decreases. These spindles are sensory receptors embedded within muscle tissue that help regulate tension and movement. When their sensitivity lowers, the signals that maintain tightness soften as well. This change does not happen all at once. Muscle fibers do not release suddenly. Instead, tension fades gradually, as if being turned down rather than switched off. Areas that have been holding effort for long periods begin to feel heavier, less alert, and more at ease. Warm water also reduces resistance within muscle tissue itself. As temperature increases, connective tissues become more pliable. Fibers slide past one another with less friction. Even without movement, this internal softening allows muscles to rest more fully. The buoyancy of water contributes quietly to this release. When the body is supported, muscles that normally work to maintain balance can reduce their effort. There is less need to brace against gravity. The water carries some of that responsibility, allowing muscles to rest without collapse. This combination of warmth and support changes how the body perceives effort. Muscles that were once alert and engaged no longer need to anticipate movement. The signals that maintain readiness diminish, and the body enters a state where holding tension serves no immediate purpose. As tension decreases, a familiar sensation often appears. Limbs may feel heavy, hands may loosen, the back may sink slightly as surrounding muscles relax. These sensations are not signs of fatigue. They are signs of reduced demand. Importantly, this release does not weaken the muscles. It simply allows them to return to a resting length. Once warmth fades and activity resumes, tone naturally returns. The process is reversible, safe, and familiar to the body. This letting go often happens unevenly. Some areas release quickly, others take more time. The neck, shoulders, and lower back, which commonly hold tension, may soften in stages. There is no need to encourage the process. Muscles respond when conditions feel appropriate. As muscle tension decreases, the body's internal signals quiet further. Reduced tension leads to fewer sensory messages traveling back to the brain. The constant background information about posture and strain diminishes. Attention is freed from monitoring the body so closely. This reduction in sensory demand contributes to the sense of calm many people notice after soaking. With fewer signals asking for adjustment, the mind has less to process. Everything feels simpler, quieter, and less urgent. It can be helpful to imagine muscle fibers lengthening gently, like fabric relaxing after being held taut. Nothing stretches forcefully, nothing pulls. The fibers simply return to their natural resting state, supported by warmth and buoyancy. Breathing often changes alongside this release. As muscles around the chest and abdomen soften, breaths become slower and deeper without effort. The rhythm of breathing aligns naturally with the relaxed state of the body. As attention rests here, there is no need to identify each muscle or track where tension remains. The process unfolds on its own. Warmth surrounds the body. Circulation supports the tissue. Nerve signals soften. Muscles let go in the order they choose. This deeper physical release sets the foundation for the next shift, as the nervous system responds to a body that no longer needs to remain alert. With muscles at ease, attention begins to drift toward rest rather than readiness, guided by signals that move more slowly now. As muscles release and effort fades, another quiet change becomes noticeable. The body begins to feel differently in space. Weight, which is usually constant and unavoidable, becomes less demanding. This shift is not dramatic. It unfolds gently as water takes on more of the body's load. When the body enters water, buoyant forces begin to act immediately. Water supports weight by pushing upward against the body, countering gravity in a steady, distributed way. This support does not lift the body out of the water. It simply reduces how much weight tissues and joints must carry. In warm water, this effect is often felt as a softening of pressure. Areas that normally bear the body's weight, such as the feet, knees, hips, and spine, experience less compression. The joints are still aligned. Muscles are still present. But the constant downward force they usually respond to is partially relieved. This reduction in load allows joints to settle into a more neutral position. There is less need for muscles to stabilize continuously. ligaments, and connective tissues are no longer pulled as strongly by gravity. The body remains supported without needing to hold itself upright. Because this support is evenly distributed, it feels different from lying down or sitting. Pressure points are fewer. The body is held from all sides rather than resting on a single surface. This balanced support contributes to the sense of ease many people notice when immersed in warm water. As pressure decreases, joint stiffness often softens. Movement, if it occurs, requires less effort. Even without movement, the body senses that it does not need to brace or prepare. The environment itself provides stability. This sensation of reduced weight also affects how the nervous system interprets posture. When the body is supported, fewer signals are sent to maintain balance. Muscles that usually stay engaged to prevent falling or shifting can relax further. The body trusts the water to hold it. The spine, in particular, benefits from this support. Without the full pull of gravity, vertebrae experience less compression. Surrounding muscles can release their constant guarding. The back often feels longer, more open, and less strained. It is common for people to notice a gentle swaying sensation while floating or standing in warm water. This movement is subtle and continuous, guided by the water rather than by intention. The body responds automatically, adjusting without effort. This gentle motion can be calming. It provides sensory input without demand. The body feels present, but not required to act. Attention settles into the sensation of being held rather than holding. Importantly, this relief does not depend on complete floating. Even partial immersion reduces effective body weight significantly. Simply standing or sitting in water provides support that changes how the body experiences gravity. As weightlessness increases, the sense of boundaries can soften. The distinction between body and environment feels less rigid. Warmth surrounds, pressure equalizes. Movement becomes optional rather than necessary. This state encourages stillness without forcing it. The body remains awake, aware, and supported. Nothing needs to be adjusted. Nothing needs to be maintained. The water does the work quietly. It can be helpful to imagine the body resting within the water rather than on it, supported from below, from the sides, and from within by warmth. Gravity still exists, but its demands are gentler here. As attention rests on this support, effort continues to fade. Muscles no longer prepare for movement. Joints remain comfortable. The body accepts the environment as stable and sufficient. This experience of reduced weight prepares the body for an even deeper shift. With physical effort minimized, internal systems receive the message that vigilance is no longer required. The sense of being held allows attention to drift inward, setting the stage for the nervous system to slow its pace and move toward rest. With the hot spring settling the body into warmth and support, changes begin to take place beneath conscious awareness. Muscles have softened. Weight has eased. With less effort required to remain upright or alert, the nervous system receives a different set of signals. The environment feels stable, and the body responds by adjusting how it regulates itself. The nervous system continuously balances between different states of activity. One state supports alertness, movement, and response. Another supports rest, digestion, and recovery. These states shift naturally throughout the day, guided by internal signals and external conditions. Warm water gently influences this balance. Heat exposure has been shown to reduce the activity of stress-related pathways. As warmth surrounds the body, levels of cortisol, a hormone associated with alertness and stress response, tend to decrease. This change does not occur abruptly. It unfolds gradually as the body interprets warmth and support as signs that heightened vigilance is no longer necessary. At the same time, activity in the parasympathetic branch of the nervous system increases. This branch supports processes associated with rest and restoration. Heart rate slows slightly. Breathing deepens without effort. Digestion becomes more active. These shifts occur automatically, guided by internal feedback rather than conscious intention. Immersion in warm water amplifies these effects by reducing sensory demand. With muscles relaxed and joints supported, fewer signals travel from the body to the brain requesting adjustment. The nervous system receives less information that requires action. In response, it quiets its output. This reduction in sensory load can feel like mental space opening. Thoughts may slow. Attention drifts more easily. The constant background monitoring of posture, temperature, and balance fades into the background. The mind does not need to track as much. Warmth also influences nerve conduction itself. As temperature increases, nerve signals related to discomfort and tension become less pronounced. The nervous system prioritizes maintenance rather than response. This shift supports a sense of calm that is both physical and mental. For many people, this state feels familiar. It resembles the moments before sleep, when awareness softens and the body prepares for rest. However, in warm water, this transition can happen earlier and more gradually, without the pressure of needing to fall asleep. The environment plays a key role here. Hot springs are often located in quiet spaces with minimal artificial stimulation. Sounds are repetitive. Visual input is limited. These conditions reinforce the nervous system's shift toward lower alertness. The body recognizes the consistency and responds accordingly. Importantly, this calming effect does not rely on distraction. The mind does not need to focus on anything specific. Instead, it benefits from the absence of demand. With fewer signals asking for attention, the nervous system can settle naturally. As parasympathetic activity increases, the body directs resources toward recovery. Muscles repair, energy stores rebalance, internal rhythms stabilize. These processes do not require awareness to occur. They continue quietly in the background. This shift also influences emotional tone. With stress-related signaling reduced, emotional responses tend to soften. There is less urgency attached to thoughts. Concerns lose their sharp edges. The nervous system no longer prioritizes problem-solving or anticipation. It can be helpful to imagine internal signals slowing, like a stream that widens and smooths as it moves into open space. The current remains, but its pace is gentler. Nothing is stopped. Everything continues at a calmer speed. As attention rests here, there is no need to encourage this shift. The body already knows how to move toward balance when conditions allow. Warmth, support, and reduced sensory input provide those conditions naturally. This state prepares the body for the next transition. With the nervous system already leaning toward rest, Changes in temperature and environment can guide it further towards sleep readiness. The groundwork has been laid gently, without force, allowing the next phase to unfold with ease. One of the reasons warm water can make people feel sleepy happens after the warmth, not during it. When the body leaves a warm environment, a quiet transition begins. Heat that was once evenly distributed near the surface starts to move outward and away. The body does not resist this change. It follows it, guided by internal rhythms that already know how to prepare for rest. During immersion, warmth causes blood vessels near the skin to widen, allowing heat to circulate freely. When the surrounding warmth is removed, those same pathways remain open briefly. This allows heat to dissipate more efficiently into cooler air. The result is a gentle drop in core body temperature. This gradual cooling mirrors what naturally happens in the evening. As daylight fades, the body begins releasing heat in preparation for sleep. Core temperature lowers slightly, signaling that the active part of the day is ending. Warm water immersion, followed by cooling, supports this same pattern without forcing it. The change is small but meaningful. A slight decrease in core temperature helps signal the brain that conditions are suitable for rest. The body does not interpret this cooling as exposure or threat. It recognizes it as part of a familiar cycle. Because the cooling happens gradually, it does not disrupt the calm established by warmth. Muscles remain relaxed. Circulation slows at a comfortable pace. The nervous system, already leaning toward parasympathetic activity, continues in that direction. This is why many people notice a wave of sleepiness after leaving warm water. It is not sudden. It arrives softly, like the final settling after movement has stopped. The body shifts from holding warmth to releasing it, from maintaining alertness to allowing rest. The timing of this cooling matters. When warmth is followed by a cooler, quieter environment, the effect is most noticeable. The contrast does not need to be strong. Even a small change is enough for the body to respond. Hot springs often exist in settings that support this transition naturally. Evening air cools, light dims, sound softens. These environmental cues align with the body's internal signals, reinforcing the shift towards sleep readiness. Importantly, this process does not require intention. The body does not need to be told to relax or prepare for sleep. It responds automatically to changes in temperature and sensory input, following patterns shaped over a lifetime. This cooling phase also influences mental activity. As body temperature lowers slightly, alertness decreases. Thoughts may slow. Focus becomes less sharp, less insistent. The mind does not disappear. It simply loses urgency. The experience is often described as feeling settled rather than tired. Energy is still present, but it no longer seeks direction. The body feels complete, finished with the effort of the day. This transition is one reason warm water has been associated with evening routines across cultures. Bathing, soaking, or resting near warmth before nightfall supports the body's natural descent into rest. The practice aligns with physiology rather than working against it. It can be helpful to imagine warmth opening the body gently, followed by cooling that allows everything to close again comfortably. The cycle completes itself without tension. Heat rises, spreads, and then fades, making room for stillness. For the mind, this process reduces the need to engage. There is nothing to analyze. The body is already doing what it needs to do. Attention can follow the sensation of cooling without tracking it closely. As warmth dissipates, the sense of containment increases. The body feels more clearly defined, more at ease within itself. The urge to move lessens. Rest becomes appealing rather than something to reach for. This readiness for sleep does not mean sleep must happen immediately. It simply means the body is no longer resisting it. The internal conditions are aligned. The pace has slowed. The quiet release of heat marks another completed cycle. Warmth did its work. Cooling completes it. Together, they guide the body gently toward rest, preparing the way for the final settling that follows. After warmth has begun to fade and the body settles into a quieter state, attention often returns to the surface, not in a sharp or focused way, but as a soft awareness of contact. Skin, which has been immersed in warm, mineral-rich water, carries subtle traces of that experience even after the water is left behind. The skin is constantly interacting with its environment. It absorbs heat, releases moisture, and responds to changes in temperature and texture. During time spent in a hot spring, this interaction becomes more noticeable, not because something new is happening, but because the pace has slowed enough to feel it. Mineral-rich water changes how the skin feels in small, physical ways. Dissolved minerals remain suspended in the water while soaking, moving across the surface with every small shift. When the water drains away or evaporates, microscopic particles can remain behind, settling lightly on the skin. Silica-rich springs are often associated with a smooth, softened feeling once the skin dries. This sensation does not come from moisture alone. It comes from tiny mineral deposits that alter surface texture slightly, reducing friction and changing how skin contacts air and fabric. The effect is subtle but noticeable. Other minerals can influence skin hydration by affecting how water interacts with the outer layers. Warm water opens pores gently, allowing moisture to move more freely. As the skin cools afterward, pores gradually return to their usual state, helping retain some of that moisture. The process unfolds naturally, without intervention. This interaction is physical rather than cosmetic. Nothing is being added artificially. The skin simply reflects the conditions it was exposed to. Mineral content, temperature, and duration all contribute, but no single factor dominates. The experience remains simple. As drying begins, sensation shifts again. Air moving across damp skin creates a mild cooling effect. Towels or clothing make contact. Each touch feels clearer, more defined, because the skin has been warmed and relaxed. Sensory input remains present, but it no longer asks for attention. This return to surface sensation can feel grounding. After internal systems have settled, noticing contact helps orient the body gently without reactivating alertness. The feeling of fabric against skin or air across arms and shoulders provides quiet confirmation of place and time. Because mineral composition in many hot springs remains stable over long periods, the sensations they produce tend to be familiar to those who return often. The skin recognizes the water. The response becomes predictable. Comfort replaces novelty. Importantly, this phase does not stimulate the nervous system. Sensations are mild, repetitive, and slow. There are no sudden temperature changes, no sharp textures. The body receives information without needing to respond. This is one reason surface sensations after soaking often feel calming rather than distracting. The skin is active, but the signals it sends are low priority. They register, then fade, allowing attention to remain soft. It can be helpful to imagine the skin holding a memory of warmth briefly, even as temperature equalizes. Not as a thought, but as a physical echo. The body does not rush to erase the sensation. It allows it to dissipate naturally. This gentle fading mirrors the broader pattern already established. Heat rose and spread. Muscles softened, weight eased. The nervous system slowed. Now, the outermost layer completes the process, releasing warmth and contact gradually. For the mind, this moment supports closure. The experience feels complete rather than interrupted. Nothing pulls attention outward. Nothing demands action. Sensation exists, then settles. As skin returns to its usual state, the body feels contained and comfortable. Boundaries are clear, but not rigid. The environment feels quiet and familiar. The sequence of changes has finished its work. This return to surface awareness marks the final physical transition. Internal systems are calm. External sensations are minimal. The body rests in a balanced state, neither alert nor asleep, ready for the deeper stillness that follows as everything continues to slow on its own. Some hot springs change very little across human lifetimes. They flow year after year, decade after decade, at nearly the same temperature, with nearly the same composition. While everything around them shifts, weather, vegetation, paths, and people, the water continues arriving in much the same way it always has. This stability is not coincidence. It reflects the pace of the processes beneath the surface. The geology that shapes a hot spring changes slowly. Rock layers move on timescales measured in thousands or millions of years. Underground pathways widen or narrow gradually. Heat from the Earth's interior is released steadily, without sudden variation. Because of this, many hot springs maintain a consistent chemical composition over long periods of time. The minerals dissolved in the water remain similar year after year, shaped by the same rock formations the water continues to pass through. Even when surface conditions vary, the source remains unchanged. Some hot springs have been continuously active since prehistoric times. Long before names were given to places, water was already rising there. Long before paths formed, heat was already being released. The spring existed without awareness, without record, simply continuing its cycle. This long continuity offers a different sense of time. Instead of hours or days, the scale stretches outward. Decades become brief. Centuries become manageable. The spring does not mark events. It does not respond to them. It flows. This constancy can feel grounding. When attention rests on something that changes so slowly, urgency has little place. There is no need to anticipate what comes next. The next moment will resemble the last. The pattern holds. For people who return to the same hot spring over many years, this stability becomes familiar. The water feels recognizable. The temperature feels expected. Even subtle changes register slowly. The spring becomes a reference point rather than a destination. In geological terms, this steadiness reflects balance. Heat continues rising at roughly the same rate. Water continues circulating through the same general pathways. Minerals continue dissolving and settling at similar concentrations. Nothing needs adjustment. The system sustains itself. This does not mean hot springs are frozen in place. Small changes do occur. Flow may increase or decrease slightly. Channels may shift over time. But these changes happen slowly enough that they blend into the background. They do not interrupt the overall continuity. The idea of something remaining active for thousands of years without significant alteration can be difficult to picture. Human environments are shaped by constant change. Buildings are replaced. Roads are rerouted. Landscapes are reshaped intentionally. Hot springs, by contrast, persist without intervention. This persistence can soften perspective. Problems that feel immediate begin to feel temporary. Concerns that demand resolution lose some of their weight. The presence of something so enduring reframes attention gently. It can be helpful to imagine a spring flowing quietly through centuries, seen by different eyes under different skies, yet remaining itself. The same warmth rises. The same water reaches the surface. The same cycle completes again and again. This sense of continuity does not require reverence. It does not ask for meaning. It simply exists. And in existing, it offers a kind of reassurance that does not need to be explained. For the mind, resting on this timescale reduces mental effort. Thoughts slow to match the pace of the system being considered. There is nothing to solve, nothing to predict. The pattern is already established. As this section settles, the emphasis shifts away from explanation and toward presence. The spring flows. It has flowed. It will continue flowing. Everything else can move more slowly now. The water remains warm. The pathways remain open. Time continues passing without urgency. Stability holds, quietly, providing a foundation for the final phases of rest that follow. Hot springs have often been places where people come together without needing to interact closely. They draw individuals into the same space, yet allow each person to remain within their own experience. Presence is shared, but attention stays inward. Across many cultures and time periods, hot springs functioned as gathering places rather than destinations built for activity. People arrived, settled into the water, and remained still. Conversation, if it happened at all, tended to be brief and unforced. Silence was common and comfortable. This form of gathering does not rely on performance or exchange. No one is expected to speak, move, or respond. The water provides a common focus, reducing the need for social cues. Each person occupies the same environment while remaining separate within it. The physical arrangement of hot springs supports this kind of quiet coexistence. Pools are often wide and shallow, allowing space between bodies. Natural edges create boundaries without walls. People can sit near one another without facing directly, reducing the sense of being observed. Warm water further reduces social demand. With muscles relaxed and posture supported, there is less need to adjust or present oneself. The body is already at rest. The nervous system does not prioritize monitoring others. In these conditions, shared presence becomes passive. People notice one another without engaging. Awareness remains broad and unfocused. The environment holds attention more than any individual within it. Historically, this kind of gathering allowed for connection without intensity. Families, travelers, and neighbors could occupy the same space without needing to coordinate or communicate. The spring itself served as the unifying element. This pattern continues in many places today. Even when multiple people share a hot spring, the dominant experience remains personal. Eyes are often closed. Movement is minimal. Sound is subdued. Each person settles at their own pace. From a sensory perspective, shared stillness reduces social stimulation. There are no rapid gestures to track, no shifting expressions to interpret. The nervous system receives fewer signals related to social evaluation or response. This reduction supports calm. The body does not need to prepare for interaction. The mind does not need to anticipate conversation. Presence becomes simple. It is worth noting that this kind of gathering differs from isolation. Others are nearby. Their presence is felt, but it does not intrude. This balance can feel reassuring. One is not alone, yet not required to engage. For some, this shared quiet provides comfort. The knowledge that others are resting nearby reinforces safety without requiring connection. The environment feels held. The soundscape supports this dynamic. Water moves continuously, masking small noises. Steam softens visibility. Individual details blur into the background. The group becomes part of the environment rather than a source of attention. Over time, this pattern of quiet gathering can influence how the body responds to social proximity. Instead of increasing alertness, closeness becomes neutral or calming. The nervous system associates shared space with rest rather than demand. This association may help explain why hot springs have remained social spaces across centuries without becoming sites of noise or activity. The environment shapes behavior gently, encouraging stillness rather than expression. In these moments, attention does not move outward. It settles. The presence of others fades into a general awareness, like distant landmarks in a landscape. They are there, but not central. This shared quiet mirrors the broader themes already established. Heat rises and dissipates. Muscles soften. Circulation slows. Time stretches. Now, even social presence becomes quiet and undemanding. The gathering holds without effort. No one directs it. No one maintains it. It exists because the environment allows it to exist. As this section settles, interaction continues to recede. The focus moves away from people as individuals and toward the shared atmosphere itself. Sound, movement, and the mind begin to narrow further, preparing the way for the deeper sensory quiet that follows. The spring continues flowing. People remain still. Presence is shared, gentle. In many hot spring environments, sound becomes one of the last sensations to remain present. Visual details soften in steam. Movement slows. What continues, almost unchanged, is the sound of water itself. The flow of a hot spring is rarely abrupt. Water rises, spills, or circulates at a steady pace. It does not surge or stop. This consistency shapes how the nervous system responds. Repetitive, low-frequency sounds tend to reduce vigilance. The mind recognizes the pattern and stops monitoring it closely. Unlike sudden or irregular noises, the sound of moving water does not demand interpretation. There is no need to identify its source or predict its timing. The sound exists, then continues existing in the same way. Attention can rest alongside it rather than tracking it. This type of sound often blends into the background quickly. After a short time, it becomes part of the environment rather than an object of focus. The nervous system registers it as stable and safe. Hot springs often produce layered sounds. Water may trickle from a rock edge, ripple across a surface, or drip slowly into a pool. These overlapping patterns create a soft texture rather than a distinct rhythm. No single sound stands out. Steam can muffle sharper noises, further smoothing the soundscape. Wind, if present, tends to move gently through surrounding vegetation or open space. These sounds align with the water rather than interrupt it. Because the sound environment remains consistent, attention naturally narrows. The mind does not scan for change. There is nothing new to detect. Awareness becomes less active and more receptive. This narrowing does not eliminate perception. It simplifies it. Sound becomes a continuous backdrop, supporting rest rather than pulling focus. The body responds to this simplicity by reducing effort. Muscles remain loose. Breathing stays even. The nervous system continues leaning toward parasympathetic activity. For the mind, repetitive sound reduces internal narration. Thoughts lose momentum. Without external variation to respond to, mental activity slows on its own. This is similar to what happens when listening to rain or waves. The sound remains present, but it does not carry information. It does not signal action. It fills space gently. Hot spring environments often amplify this effect by minimizing competing sounds. Remote locations reduce traffic noise. Stone and earth absorb echoes. Human voices remain low or absent. The result is a soundscape with very few elements. When fewer sounds are present, the mind stops sorting and labeling. It no longer asks which sound is closest or loudest. Attention rests in a broader, less defined state. Over time, even the sound of water can fade from conscious awareness. It does not disappear. It simply no longer occupies attention. The nervous system acknowledges it without engaging. This fading is a sign of settling rather than withdrawal. The environment remains intact. Perception remains open. The body simply no longer needs to monitor. As sound recedes in importance, other sensory inputs follow. Visual detail blurs further. Physical boundaries soften. The world becomes less distinct. This gradual reduction does not require effort. It happens because nothing interrupts it. The environment provides no signals that demand response. The steady movement of water continues beneath awareness. Heat still rises and disperses. Minerals still circulate. Time passes at its usual pace, even as perception slows. This stage prepares the mind for deeper quiet. With attention no longer anchored to sound, there is less to hold on to. Awareness can drift without losing orientation. The sound of water remains, but it is no longer central. It supports stillness rather than defining it. Everything continues quietly as the last layers of sensory focus begin to loosen, allowing rest to deepen naturally. At a certain point, the environment no longer needs to be described in detail. Sensory information remains present, but it arrives without clarity or emphasis. Edges soften, distinctions blur. Attention no longer moves outward in search of detail. Steam plays a quiet role in this shift. As warm air rises from the water, it obscures distance and form. What remains visible is close and gentle. Farther details dissolve into light and movement. The world feels smaller, more contained. This narrowing of perception reduces the amount of information the mind needs to process. With fewer shapes to identify and fewer distances to judge, awareness becomes simpler. The nervous system responds by lowering its level of engagement. Visual input fades first. Colors lose sharpness. Boundaries lose definition. Movement becomes slow and indistinct. Nothing needs to be followed. Sound has already softened into the background. What remains is more like texture than signal. The body hears without listening. Touch remains, but even it becomes diffuse. Water supports weight evenly. Air rests against skin without contrast. There are no sharp temperatures or sudden contacts. Sensation exists, but it does not separate itself from the whole. This combination allows attention to narrow naturally. The mind does not withdraw. It simply stops reaching outward. Awareness settles closer to the body, closer to the present moment, without effort. Reduced sensory input supports mental quiet. With fewer external cues to respond to, internal activity slows as well. Thoughts arise less frequently. When they do, they carry less urgency. They pass without pulling focus. This narrowing is not emptiness. It is fullness without detail. Everything needed is already present. Nothing additional is required. In this state, time becomes less noticeable. Without changes to mark its passage, moments stretch and blend. The distinction between now and a moment ago softens. The experience feels continuous rather than segmented. The nervous system recognizes this environment as safe and stable. There are no signals that require action. No changes that demand adjustment. The body continues resting into itself. Breathing remains steady. Heart rate stays low. Muscles remain loose. All systems continue operating at a quiet baseline. Steam continues rising. Water continues flowing. Heat continues releasing gently. These processes happen without variation. They do not call attention to themselves. The world becomes simpler, not because information disappears, but because it no longer competes for awareness. Everything exists at the same soft volume. This is often the point where the desire to move fades completely. The body feels settled. There is no reason to adjust posture or shift position. Comfort feels complete. For the mind, this narrowing creates space. With less incoming information, there is less to interpret. The mind does not need to plan or reflect. It can remain present without effort. This state closely resembles the threshold before sleep. Awareness is still there, but it is light. The body remains awake, yet no longer alert. The narrowing continues gently. Visual input fades further. Sound remains distant. Touch blends into warmth and air. The environment holds everything together. Nothing needs to change from here. The system has reached a balanced state. The final transition does not require explanation. It happens on its own. As this section settles, attention loosens further. The environment becomes a single, quiet field, rather than a collection of details. The body rests within it, ready to release the last traces of effort as everything moves towards stillness. At the deepest level, hot springs are not dramatic places. They do not erupt or announce themselves. They do not rush. Heat rises from deep within the earth and releases itself gently at the surface, without urgency and without display. This release has been happening long before it was noticed, long before it was named. Energy moves upward, spreads outward, and dissipates. Nothing resists the process. Nothing accelerates it. The cycle completes itself quietly. The earth holds immense internal heat, generated slowly and steadily. In most places, that heat remains sealed away. In a few locations, pathways open just enough to allow warmth to escape. When it does, it arrives as calm rather than force. Hot springs exist at the meeting point between deep energy and surface stillness. Heat that once moved through solid rock now moves through water and air. It slows, it softens, it becomes something the body can rest beside. There is no conflict in this exchange. The earth does not lose its heat. The surface does not struggle to contain it. Energy flows, then releases, then continues on its way. This balance is what makes hot springs feel restorative rather than intense. Nothing is pushed, nothing is taken. The system remains whole. By the time attention reaches this point, there is very little left to notice. Sensation has softened. Sound has receded. Thought has slowed. The mind no longer reaches outward. Awareness rests without direction. There is no object to focus on, and no reason to search for one. Everything that needed to happen has already happened. The body feels complete. Warmth has done its work. Cooling has followed. Muscles remain loose. Breath moves easily. Circulation flows at a quiet pace. The nervous system no longer shifts. It remains settled. Signals move slowly, without urgency. There is no call to respond. Time feels wide here. Moments stretch without needing to be measured. The distinction between one moment and the next loses importance. The spring continues flowing, just as it always has. Heat continues releasing from deep below. Water continues rising, spreading, and cooling. These processes do not depend on observation. The body does not need to stay alert to remain safe. The environment offers no demands. Nothing changes abruptly. Nothing requires attention. In this stillness, the mind can rest fully. Not because it is told to, but because there is nothing left to hold on to. Thoughts may appear briefly, then dissolve. Sensations may flicker, then fade. Awareness remains, but it is light and unanchored. This is not an ending. It is a continuation without effort. The cycle does not stop. It simply no longer needs to be followed. The balance between deep earth energy and surface calm remains intact. Heat releases, stillness holds, everything exists together without tension. Nothing more needs to be explained. Nothing more needs to be understood. The water flows, the heat releases, the body rests, and the mind, no longer occupied, is free to drift wherever it naturally goes, carried gently by the same quiet forces that have been moving beneath the surface all along.